Today I'm going to show you how to model reactions that are happening in aqueous. So I already have a key on the left side, and I'm just going to kind of walk you through the problem as we would do it. So when I'm reading, it says there's going to be 8 moles of solid calcium metal reacting with 4 moles of iron 3 chloride. That is what I model in the reactant box. I do not model the balanced equation. I do if it doesn't tell me what I'm starting with, but this time it does tell me exactly what I'm starting with. So the first thing I want to do then is put those things in the boxes. So we need 8 calcium metals. Now, because it says it's solid, that calcium metal is going to sink to the bottom, and there's going to be 8 of them. 3, 4, 5, 6, 7, 8. There are no charges as well, because the only time we have a charge is when it's in an ionic compound, because ionic compounds are made of charged particles. They're made of ions. This is a metal though, so there is no charge. Then 4 moles of aqueous iron chloride. Now, iron chloride, if we have 4 iron chlorides, when this is aqueous, it's going to break up into 4 iron 3 pluses, because that's the charge of iron in this compound. And then there are going to be 12 of the Cl minuses. You do have to look those up on your ion sheet to figure out what they are. The iron has variable charge, so I was able to figure out it was 3 plus. Since there's 3 of these minus ones to balance the charge, that must have been 3 plus. All right, so that's what I'm going to draw in the box down here. 4 Fe3 pluses and 12 Cl minuses. So 4 Fe3 pluses and then 12 Cl minuses. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Doesn't really matter where you draw these, by the way. I've just kind of done it randomly. Now, what I need to keep in mind for the aqueous ones is that they have charges. So they had a charge up here, and I need to include those in my picture. Okay, so that's what I'm going to do now, is just go in and put those charges into my picture. So the iron was 3 plus. And those chlorines are each minus 1. All right, so now I'm ready to look and see how much product will I make. All right, and to figure that out, you do have to look at that balanced equation, and then you're going to kind of pair everything up based on the stoichiometry, based on those mole ratios in the balanced equation, to see how many sets of products we can make. So when I look at the balanced equation, I see that I need 3 calciums and 2 iron chlorides. So I'm going to kind of partition this off like that. 3 calciums and 2 iron chlorides. So 3 calciums, that's this, 2 iron chlorides. So I need 1 iron chloride, 2 iron chloride. So I have enough to make 1 set of products. So I'll make 3 calcium chlorides and 2 irons from that. But I actually have enough to make a little bit more as well. So I have enough to make another set of products here. So I can make another set of calcium chloride. So that's a total of 6. Maybe I'll just write that. So now I can make 6 CaCl2s and 4 Fes, because I can make twice as much. I have 2 sets of reactants, so I can make 2 sets of products from that. Notice I also have some of this left over. That also needs to make its way to the other side. That's my excess reactant. So I could actually go ahead and answer that part. The limiting reactant is my FeCl3, because that ran out. And then my excess is that calcium, and I want to draw it on the other side in the same state of matter that it was. So that is my excess. All right, and then I need to draw those products on the product side. So I have 6 CaCl2s and 4 irons. Now those 4 irons are solid, and the solids do not have a charge, so they sink to the bottom. So I'm going to draw that first. 4 irons, 1, 2, 3, 4. And then I need to draw 6 calcium chloride. So that would be 6 of the Ca2 pluses. I do have to look up and see what is the charge of a calcium ion. It is 2 plus. So 1, 2, 3, 4, 5, 6. And there are 12 chlorines. Goodness, it didn't make this easy for us. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So everything dissociated. Because it's aqueous, that means it's breaking up into ions that make it up on that right side. And then I just need to go in and add those charges. Again, my calcium is 2 plus or plus 2. And then these are all minus 1. Now another thing you can do when you're all done to try to catch yourself if you made a mistake is to look and make sure the law of conservation of mass was held true, because it should be. So however many of those pink dots are on the left, there should be the same amount on the right. However many blue dots are on the left, there should be the same on the right. However many green on the left, there should be the same amount on the right. That's one way of kind of checking your work. Okay, everything floating should have charges. Everything solid on the bottom, no charges. Okay, and make sure you also include that excess reactant. Now our theoretical yield comes from our picture. You could do some mole-to-mole stoichiometry if you wanted to, but really I'm just looking to see, well, how much did I make? And you can count that in the picture. We have 4 irons, we said, so 4 moles of iron. Remember, every particle that we have or molecule at the beginning, we're representing that in the picture. 1 mole is a molecule. So we have 4 moles of iron, and then we also made 6 moles of CaCl2. All right. I hope that was helpful. You do just have to practice, honestly. But if you have any questions, feel free to send me an email. Bye, everyone.